Right now, somewhere on Earth, someone is being born. Within a year, that tiny human will start babbling. Within 2, they'll be forming sentences. No one will sit them down with a textbook. No one will drill them on grammar rules. They'll just start speaking. Meanwhile, the smartest chimpanzee on the planet, raised by humans, given every advantage, taught sign language for years, will never do that. Never form a sentence. Never ask why. So what happened to us? Why do humans talk when every other animal on Earth, no matter how smart, doesn't? This isn't just a cute trivia question. Language is arguably the single biggest reason humans run this planet. We didn't win because we're the strongest. A gorilla could tear us apart. We didn't win because we're the fastest, or because we can see in the dark or fly. We won because we could do something no other species could, pass complex information from one mind to another, and stack that knowledge across generations. A single human alone isn't that impressive. But a human who can say, "Don't eat that berry, it killed my uncle," and be understood and believed, just saved the whole tribe a very costly lesson. Multiply that by thousands of generations, and you get rockets, hospitals, the internet, and you watching this video. So the real question isn't just why do we talk, it's how did talking turn us into the dominant species on Earth? The first theory people usually reach for is physical. Humans have the right equipment. And it's true, we do have a uniquely shaped vocal tract. Our larynx, the voice box, sits lower in our throat than in other apes. That drop creates a longer resonating chamber above the vocal cords, which lets us produce a huge range of distinct vowel sounds. But here's the problem with stopping there. A lower larynx explains why we can make lots of sounds. It doesn't explain why we bother. Plenty of animals have decent vocal control. Parrots can mimic almost any sound imaginable, and they still don't have language. So the vocal tract is a necessary ingredient. It's not the recipe. There's also a genetic piece to this puzzle, a gene called FOXP2. Researchers found that mutations in this gene cause severe speech and language disorders in humans. It's not the language gene in some magic single-switch way. Genetics is messier than that. But it's one of several genes that appear to help wire the brain circuits used for the fine motor control speech requires, and for sequencing sounds and words correctly. So we have the hardware. Now the real question: why did evolution bother building it? Here's one of the most compelling answers from anthropologist Robin Dunbar. He noticed something odd about primates. They spend enormous amounts of time grooming each other. Not just for hygiene. Grooming is social glue. It releases feel-good chemicals, builds trust, and cements alliances. The problem is, grooming only works one-on-one. You can only pick nits out of one friend's fur at a time. Dunbar's theory is that as early human groups grew larger, too large to bond through one-on-one grooming alone, we needed a way to maintain social bonds with many people at once. And talking does exactly that. You can groom an entire group with a story, a joke, or let's be honest, some gossip, all at the same time. In other words, language may have started in part as a way to keep track of who's trustworthy, who's cheating, who's an ally, and who's a threat. Social bookkeeping at a scale that grooming alone could never handle. That's why even now, so much of everyday human conversation isn't about hunting strategy or the weather, it's about other people. Who did what? Who said what? That's not a modern flaw, that might be the original point. There's a second, closely related answer: coordination. Early humans hunted large, dangerous animals, not with brute strength, but with teamwork. One group driving prey toward another group waiting in ambush. That kind of plan requires more than instinct. It requires the ability to describe something that hasn't happened yet. Think about how strange that actually is. A wolf pack can coordinate a hunt using instinct and body language, but a wolf can't say, "Tomorrow at dawn, you two circle around from the east while we wait by the river." That sentence describes a future, hypothetical event. It requires imagining a plan and transmitting that imagined plan into someone else's head, intact. No other species does this. Not really. And this ability to describe things that are not physically present, that haven't happened yet, or that never happened at all, is arguably the most powerful tool language gave us. It's the same tool that lets a modern company plan a product launch 2 years out, or lets a teacher describe an ancient civilization to a room of 10-year-olds who weren't there. Once you can talk about things that aren't in front of you, you can plan, teach, warn, and imagine. Here's the part that makes all of this even stranger. Talking only works if both people understand that the other person has a mind too. This is called theory of mind, the ability to understand that other people have their own beliefs, knowledge, and perspective, separate from your own. When you say, "Watch out, the floor is wet," you're not just making noise. You're modeling what the other person doesn't know yet and filling that specific gap. Most animals don't clearly do this. Even our closest relatives show only limited, debated evidence of it. Humans, on the other hand, develop this skill very early, and it's arguably the real engine behind language. You can have the fanciest vocal tract in the animal kingdom, but if you can't imagine what's going on in someone else's head, you have nothing worth saying to them, and no way to know what they need to hear. So maybe the deepest answer to why do humans speak isn't really about sound at all. It's about the fact that we're unusually good at imagining what's inside another person's mind, and language is simply the tool we built to bridge two minds together.